Okay, this assignment's got 5 problems. You're applying scientific notation to some real life stuff. Now, example 1 says you got to be on the document too. It says the bending of light when it passes from one substance to another is called refraction. The index of refraction is equal to the velocity of light in air divided by the velocity of light in the substance. The velocity of light in air is 1.86 times 10 to the 5th power miles per second. The velocity of light air through glass is 1.23 times 10 to the 8th power miles per second. Determine the index of refraction of glass. Give the numbers in scientific notation rounded 2 digits. They give you the formula, okay? So number 1, the index of refraction is what I'm trying to figure out. So what's the velocity of light in air? Well, it looks to me like 1.86 times 10 to the 5th power. You just write that on top. Okay, and then the velocity of light in the substance is 1.23 times 10 to the power of 8. Now remember how to divide scientific notations. You break it up. 1.86 divided by 1.23 and 10 to the 5th divided by 10 to the 8th. Okay, so I just divide 1.86 by 1.23. I get 1.51. Decimal's in the right place. There's 1 digit before it, so it's a 1, so that's good. Times 10. Remember, dividing, you subtract the exponents. You subtract the bottom from the top. 5 minus 8 is negative 3. Okay, that's the answer. That works. I don't care about labels. Okay. Number 2. A formula in electricity for determining power when current resistance is known as P equals I to the power of 2 times R. P is the power in watts. I is the current in amperes. R is the resistance in ohms. Determine the power in watts when I equals 3.80 times 10 to the power of negative 5 amperes and R equals 2.90 times 10 to the 5th power ohms. Give the answer in scientific notation rounded 2 digits. So you're solving for P. Okay. Now you got I to the 2nd power. I is 3.80 times 10 to the negative 5th. Now listen to this. Since that's to the 2nd power, you're going to put I down twice. 3.80 times 10 to the negative 5th power times, and you're going to do the same thing, because that's what a 2nd power is. You just multiply the same thing times itself. Times R, and R is going to be 2.90 times 10 to the 5th. Okay, so I don't have any division. I just break up the multiplication. So I take 3.80 times 3.80 times 2.90. And then I'll take 10 to the negative 5th times 10 to the negative 5th times 10 to the 5th. If you don't have any division, this is going to be how you line it up. Okay, so 3.80 times 3.80 times 2.90. They want 2 digits, so 41.88. Now with your base 10s, you need to add the powers, okay? Negative 5 plus negative 5 is negative 10, but then if I add a positive 5, it's negative 5. So we have 41.88 times 10 to the power of negative 5, but I have 2 digits in front of the decimal. That's incorrect. You need to move it so you only have 1 digit in front. Okay, so you got 4.188, but then you got to carry that one place you moved it over here. You moved it left, so when you move it left, you add. So it's negative 4, 10 to the negative 4th power. The examples follow like the assignment. Again, the reason I put this down twice is because it was I to the 2nd power. Okay, example 3. The amount of expansion of metal when heated is computed as follows. Expansion is the original length of a metal times the linear expansions per unit of length per degree Fahrenheit. They give you all that in the table. Times the temperature change. Calculate the amount of expansion for the metals shown. Give the answer in scientific notation rounded 2 digits. So number 3, what you're going to write is aluminum, copper, carbon. Okay. Okay, so here's the thing, expansion, that's what you're figuring out. So you got the original length of aluminum, 6.7520. It's a standard number, it's not in scientific notation. You don't need to write it in scientific notation. Times linear expansions per unit of length per degree Fahrenheit. It's 1.244 times 10 to the negative 5th power. Put these in parentheses as you're doing it. Times the temperature change. Now the temperature change, you got to do some calculating. You need to subtract those two because it was 68 to begin with. Now it's at 225. So to find the change, you just subtract. Okay, 157. Okay, so it's all multiplication. So I'm going to take 6.7520 times 1.244 times 157. And then I just got the 10 to the negative 5th power. Okay, so it's whatever times 10 to the negative 5th. I don't have to multiply that by anything. It is what it is. Okay, go 2 decimal places, 1,318.72. So I wind up with 1,318.72 times 10 to the negative 5th power. Now you got to write have the decimal in the right spot. You need only one digit in front. Okay. Now you're there. Now you moved it 3 places as opposed to 1. You moved it left, so you're going to add. Okay. So we got 1.31872 times 10, negative 5 plus 3 is negative 2. So that's your answer for aluminum. Okay. Copper. Okay, so the original length of the copper is 35.7520 times the expansion's 9.0, just put 9 times 10 to the negative 6th. And then to find your change, you take 97 minus 35. 62. Okay. So same thing, I got 35. The standard numbers I have is 7520, my bad, times 9 times 62. Then for the base 10s, I just got the 10 to the negative 6. Don't have to do anything with that because that's the only one. 35.7520 times 9 times 62. Big number 19949.62. So that's what you end up with, 19949.62 times 10 to the power of negative 6. Now you need to move that decimal. Okay, so I moved it 4 times left, so I need to add 4 to my exponent. So I got 1.994962 times 10 to the negative 2nd power. Okay, then carbon, same thing. Okay. The original length, I've got 3.0950 times 6.330 times 10 to the negative 6th times, and then my temperature change, I need to subtract 743 minus 84. Okay, 659. Okay, so we got the 10 to the negative 6, nothing to do with that. Then we just multiply the three standard numbers together. 3.0950 times 6.330 times 659. Okay, 12910.70. Move the decimal. So 1.291070. You moved it 4 times to the left, so plus 4 times 10 to the negative second power. Technically, if you want to just, on your answer sheet, if you want to just type 1.32 times 10 to the negative second, that's fine. And 1.99 times 10 to the negative second, 1.29 times 10 to the negative second, I'm good. Kind of makes more sense to me to write them, abbreviate them. Okay. Okay, example 4. The wavelength of radio waves is calculated using the formula L equals V divided by N. And it says what V is. The L is the length. V is the velocity of radio waves in kilometers per second. N is the frequency in the cycles per second. Calculate the wavelength at the V equals 2.5 times 10 to the 7th and N equals 2.24 times 10 to the 5th cycles per second. Give the answer in scientific notation. This is pretty quick, easy problem. Your V is 2.5 times 10 to the 7th, and your N is 2.24 times 10 to the 5th. Okay, so remember division, you break it up. Multiplication, you break it up too, you just do it differently. Okay, 2.5 divided by 2.24, 1.12. I will not have to move the decimal. Then you just get rid of that. You subtract 5 now, and that's 10 to the second answer. Okay, last problem, number 5. When uranium splits, energy is released. The change in energy is given by the following statement. The change in energy, and they express that in a unit called ergs. It's equal to the change in mass times the velocity of light. Determine the change in energy when 250.675 grams of uranium are split and 232.334 grams remain. The velocity is 3.00 times 10 to the 10th centimeters per second. Give the answer in scientific notation, round it 2 digits. Okay, so change in mass. To find the change in mass, what you need to do is subtract these two amounts, because it was this much to begin with, then they split it, now it's at this much. So you need to take 250.675 minus 232.334. And that's your change in mass. To find the change in anything, you just subtract the two amounts if they don't give it to you. Okay, so 18.341 times the velocity of light, which is 3 times 10 to the 10th. It's just multiplication then. Okay, so you got the 10 to the 10th solo. Okay, you don't have to multiply that by anything. You need to multiply the 18.341 times 3. 55.023. Okay, you got 2 digits in front of the decimal, move it so there's 1, so you add 1. So it's 5.5023. If you want to just put 5.50, that's fine, times 10 to the 11th. Okay, that's it.